Alright, imagine this. There are entire planetary systems out there with no star in the middle. Just planets, moons, and maybe some debris, and it's just wandering through the galaxy in the dark. We call these rogue systems, which are free-floating planets that aren't really tied to any sun or star at all. And the James Webb Space Telescope just gave us our best look yet at these sort of rogue systems. That's not just rare, it's a cosmic curveball. And stick with me till the end, because this could really change the way we think about where life might exist in the universe. And I'll try and explain why.
When I was looking at my YouTube statistics, I found out that only 4% of my viewers are actually subscribed to the channel. So if you enjoy this kind of content, please do subscribe. It's literally free for you to do, and it helps me a lot. Thank you, and let's get back to the video.
So what exactly did James Webb Space Telescope spot? So what it did is it looked deep into the Orion Nebula, basically one of the galaxy's biggest baby star nurseries, and it found these pairs of planets floating together with no star in sight. Now, astronomers are calling these planets jumbos, which is short for Jupiter mass binary objects, because obviously they're about the size of Jupiter and they come in twos. But this is the thing, they weren't just a couple. James Webb Space Telescope picked up evidence of dozens of these pairs. That's way more common than anyone really expected. It's like looking into a daycare and realizing that half the kids there are missing parents, hanging out on their own, and are also twins, which is kind of insane. So normally when we build models of how planets and stars form, everything is really centered around the star. The star is the anchor, it's the heat source, the gravitational boss. The best way we can detect these sort of rogue planetary systems is mainly by using its parent star. Essentially, we use what we call the transit method. We observe a star and we try to look for subtle changes in its light. As a planet passes through the front of the star, we can see a sort of dip in the star's spectra. You could also see possibly with gravitational microlensing by detecting a brief enhanced brightening of a more distant star as a planet-hosting star passes in front of it. Either way, both of these methods require a parent star behind the exoplanet that we're trying to detect. But like I said, these ones don't have a parent star, which makes them harder to detect. So here's where James Webb Space Telescope's power really shines. Free-floating planets are really tiny compared to stars, and they barely give off light like I mentioned. But they do have a faint glow in the infrared range. That's exactly what James Webb Space Telescope's specialty is. In mid to late 2024, astronomers zeroed in on 8 of these young, wandering worlds. And what did they find? They found that 6 of them had extended infrared emissions, which basically means that they had warm halos of dust surrounding them. And that warm means that they emit infrared. And that warm halo of dust isn't just random fluff. That's a disk, which is the same kind of structure that forms around baby stars. And what's even more wild? Webb even picked up grains of silicate, which are tiny crystals of rock inside those disks. That's the first step in making terrestrial planets. Now, until now, silicates have really only been found around stars or brown dwarfs, and seeing them around Jupiter mass loners, that suggests that these systems could actually go on to possibly form their own rocky planets or moons. Mini solar systems, but just scaled down by a factor of 100 and surrounding a Jupiter-sized planet. Now, to understand why this is a big deal, we want to understand first how planets normally form. Now, picture a massive cloud of gas and dust collapsing under gravity. The densest part forms a new star, and the leftover gas flattens into a spinning disk. Inside that disk, dust grains collide. They then stick together and slowly grow into what we call planetesimals. Over millions of years, those planetesimals merge into planets, which are then orbiting the parent star. Now, the star doesn't just sit there, it sets the rules. Its heat carves out zones. Closer in, you get rocky planets and hotter planets, and farther out, you get icy giants, sometimes gas giants like we have in our own solar system. The star's gravity keeps everything stable, and it basically serves as the conductor of the whole planetary orchestra or something. I mean, that's cool, but this is the twist. JWST is showing us systems that pretty much skip the conducting entirely. So how do you get these starless systems? How do you get these planets without a parent star? Now, there are 2 big theories. One is that these planets did form around stars originally and then got kicked out, similar to rogue planets. If you haven't checked out my video on rogue planets, click the link. I'll attach it on this video, and there's also a link in the description. But one of the theories is that these planets are just rogue planets. They got kicked out of their parent solar system. Maybe a close encounter with another star flung them away, or there's some sort of gravity tug of war in crowded clusters, and it just yeeted them into interstellar space or something. But that's just one theory. Okay. The other possibility is that they formed directly in the nebula, almost like mini stars that ended up not having enough mass to ignite nuclear fusion. I mean, think of them as basically failed stars, not just single loners, but pairs bound together by their own weak gravity, and they could have been stars, but instead they just weren't even born. Okay, so what's the big deal beyond astrophysics nerd points or whatever, right? Like, why is this such a crazy discovery? Either our star-focused models are incomplete, or maybe nature has a whole other playbook for making planets that we've barely even considered. Honestly, both options shake up astrophysics in a big way. This discovery really forces us to think about how common these kinds of planets really are. If free-floating worlds and free-floating solar systems, I guess free-floating planetary systems actually, are this abundant, the universe might be way more packed with planets than we thought. We've been essentially counting stars and assuming that planets scale with them, but now there's like a whole population of starless, wandering planets that we haven't even tallied. And that, one, is really cool because there's a lot more exoplanets that we really know about. And two, that means there's a much higher chance that we could find life on one of these planets than just looking for planets that have stars, obviously. Now, if you have planets out there without stars, the question is, could they still support life? And surprisingly, the answer is yes. Moons around giant planets could have tidal heating, like Jupiter's Europa or Saturn's Enceladus. And even without sunlight, underground oceans could stay liquid, which obviously means that there could be life. In theory, this means that rogue systems could carry habitable environments. They're just way harder for us to detect. Does this mean that we found exactly what we're looking for? A system that sort of surrounds a planet instead of a sun? Not exactly. But these sorts of grains that we're seeing, the silicates, show that there is a possibility that planets about the size of Jupiter have really the potential to possibly serve as the gravitational center point of a new type of system, which we call a planetary system instead of a solar system. Entire planetary systems with no stars. That's pretty much a wild new chapter in cosmic science. I mean, Webb is literally rewriting the rules in front of our eyes, and we're just getting started. Thanks for watching this video, and leave in the comments below if you think there are any other places we're not looking that planets might be. Hit the subscribe button so you don't miss the next time that the universe basically flips our expectations upside down, because trust me, this is not the last surprise James Webb Space Telescope has in store. And keep expanding your universe, guys. See you next time.
Don't forget to like and subscribe. It's free, and you can change your mind at any point in time, and it really helps me out as well.